And for this one is human rights and engineering education. And as I already mentioned, Professor Mohammed Zaman, or is it more appropriate to say doctor?
Just Mohammed is fine.
Okay, all right. So I'm going to turn it over to you, and we will listen with great interest. Thank you very much.
Thank you so much. Welcome to the second section, and I'm really glad and honored to be here. Thank you so much, Darshan. I'm really glad and honored to be here. In the next hour or so, we're going to talk about engineering education and human rights. I'm joined by two wonderful colleagues, Dr. Mira Olson and Dr. Bernard Amadei, who are going to talk about some of their experiences in teaching some of these things. Before that, I was told to make a few announcements. One is that on Slido, you can vote which questions you want to be asked. There are about 300 people on Zoom right now. So they're asking questions, and you can sort of share your thoughts. That's the first thing. I will also, given the fact that many of us will have an opportunity here to talk in person, I will prioritize the questions on Zoom, if that is okay with people, because they will not have the ability to do that, and I'll try to take a few questions together. As questions come up, as you add questions, but feel free to vote as well. As I was telling colleagues here, that is something I cannot do. I cannot look at the QR code and write a question and vote and listen at the same time, but I'm sure you can. The issue of engineering education and human rights is one that is, I think, one that is important. This is also something that came up in the surveys. A number of colleagues who filled out the survey wanted to see how do you operationalize this. We heard already from examples from Maya as well as Shireen, how they're doing it, and here you'll see some more examples as well. Just for context, I'll speak for about 7 or 8 minutes, and then Bernard will, and then after that Mira will. So my home department is biomedical engineering. I teach in that department, but I also direct the Center on Force Displacement, and I'm really sort of honored to be a part of that center that is interdisciplinary in many ways. So the associate director comes from English and gender studies, and the director of programs comes from international relations, and we have sort of data scientists and engineers, but also humanists. So one of the things that we often don't do in engineering is that we would have collaboration with social scientists, but not philosophers or historians or writers. So one of the things we want to do is to be able to bring that part as well of humanities. So here I'm going to give an example from a course that I started teaching last year and now has become a permanent part of the undergraduate curriculum at Boston University in biomedical engineering. So the first question we should ask is, why should we care about forced displacement? The displacement of people because of conflict, climate change, persecution, xenophobia. And of course, this is an issue of growing social and global significance. It's an issue that comes up in election campaigns in this country, in Australia, in EU, and elsewhere. So greater conversation is happening all around us on the issue of migrants or forced displacement. Forcibly displaced communities are unique in some of the challenges that they face in health, in housing, in access to resources and infrastructure. These challenges are also unique because they're complex and require a holistic understanding. Why do people move? Where do they end up? Who's providing care? Who's providing resources, and how do we think about that? And of course, the role of humanitarian agencies is important and oftentimes lacks what engineering can offer. And it's not about sort of developing tools or technologies, it's also system analysis. It's also understanding logistics and delivery and quality control and things of that nature. And despite a growing need for engineers to engage with these challenges, there has been little, very little, that has been done to incorporate. Some of the things that we have seen have been in the domain of humanitarian engineering, which is often the case of emergencies. But we know that forcibly displaced communities might be displaced for 75 years or 40 years, whether you're looking in the Middle East or East Africa or Pakistan. Some of these communities are in protracted crises. The humanitarian crises are evolving and complex in many ways, and oftentimes that is not something that is discussed in engineering. So when we did the landscape of engineering curricula, what we found was that there was a lot of emphasis on design-based courses, but they do not always provide students with a background. Why do people displace? Where do they end up? What are the challenges, economic, legal, social, and otherwise? Often courses focus on a select few issues, such as water and sanitation. Very little attention is paid to health or logistics. Existing frameworks also tend to consider narrow definitions of displacement. They wouldn't necessarily look at people who are stateless or who are sort of displaced for 40, 50 years, second or third generation, where you inherit the title of a refugee or identity of a refugee. And detailed analysis of current technological solutions are poorly understood. The ethical component is often lacking in terms of the long-term impact on these communities. And finally, focus on challenges after a destination is reached. So imagine somebody who's starting their journey because they're forcibly displaced from South America. Oftentimes, we are not thinking about what happens when they reach the Texas border, what happens when they're on the other side of that border, and challenges that they may face there. And thinking deeply about this is a collective responsibility. It is not just sort of the social scientist or somebody who works at a migrant shelter, but also engineering and engineering students. So in these conversations, I've had this extraordinary, absolutely extraordinary privilege to work with Committee on Human Rights, and many of the colleagues here were part of these conversations that we had first in 2023 and 2024 to take a stock of what is out there, what is missing, what is the student demand, what is the interest, what are the logistical challenges. And we had 2 workshops, first in the early summer of, spring of 2023 and then summer of 2024. And out of that came sort of this understanding of where the gaps are, what can be done. And it doesn't have to be in biomedical engineering alone. It could be in civil engineering or mechanical engineering or electrical engineering, but kind of a scaffold of how do you really do these kinds of things and offer courses that can be offered again and again and again, and can really sort of benefit a generation of students and instructors as they go along. You'll see some of the familiar faces in this room in the middle picture. I'll give a specific example of what happened at my university, at Boston University. It was originally offered as a pilot course, but given the student interest, it became a permanent course. So initially, I thought there would be 10 people, but the moment I sort of opened up the registration, it was full, and then I said, okay, 20, and that was full, and I said 30. Eventually, the fire marshal code said no more. So that was the upper limit, and it happened again this year as well. There's a tremendous demand, even before I offered the course, right, that students are really eager to learn some of these concepts. And the idea here is to allow students to develop a holistic understanding of health, because they teach in biomedical engineering, of forcibly displaced persons, understand the drivers of displacement, develop knowledge of mathematical models and risk, and also then design. There are 3 main pillars of the course here, and I'm happy to, the syllabus is open, and I'm happy to share it with anyone who's interested. But the 3 main pillars are, first, a holistic understanding of what do we think about when we think of somebody being a refugee. Why do they move? Where do they go? How do they move? Things of that nature. And in that, we have both readings that are non-technical in the sense that there would be historical literature, there would be fiction, there would be literature that they would read, as well as lived experiences. They would interview people who have lived experience. They would interview people who have who work in NGOs, so different from a typical engineering course. And then they sort of conceptualize these questions into mathematical models or frameworks that would be your typical engineering approaches, right? How do you look at disease dynamics? How do you look at sort of the function of a technology? How do you sort of see whether a technology breaks down or not? And then finally, they work in small groups to design interventions. And the goal here is to look at solutions in places that you may not hear about in news. So when we started offering the course, of course, in the news we had challenges of Gaza. But very few people knew about what was happening with the Rohingya anymore. The students just didn't know. Or communities, indigenous communities in Colombia, or migration in the Sahel region. And the point was that the students have to go beyond the newspaper articles to really dig deep in understanding this and learn issues that they may not have heard about to be able to understand that. So what are some of the takeaways and lessons learned for the instructors, myself and others who have offered similar courses? Importance of shifting mindsets in courses like these is important, that we are all speaking the same language. We are all finding a common vocabulary of how to think about this. The complexity of effectively incorporating lived experience is important, to be able to understand that there are similarities and also contextual differences. And how does that feed into engineering design? How do we sort of incorporate some of these questions? Feeling of having a community in the process of piloting these ideas was absolutely a very, very, very positive thing. Because oftentimes this can be overwhelming, it can be depressing, but knowing that there are colleagues who are thinking the same way with you. There are people out there both on campus and beyond campus was uplifting and something that the students really enjoyed. The students, and these are sort of just a summary of their comments, is that there is no one-size-fits-all solution, right? You have to balance economics and ethics and longevity and sustainability, and the students having to think and sort of make decisions about that was absolutely important in the real-world sense. The students said that this was the first course that actively engaged ethical concepts more than an afterthought. In many engineering departments, and my department is no exception, ethics is an afterthought. You teach something, and ethics is something that nobody shows up on a Friday afternoon from 3 to 5, and you sort of fulfill that requirement because you have to, not because you really are engaged in those kinds of things. Importance of working across disciplines, reading literature, reading lived experiences and biographies and autobiographies, interviewing people, writing op-eds. These were the kinds of things that were typically not offered in engineering courses, but something that we were able to do. And students, of course, enjoy and gain transferable skills, but feel they will lose an ability to continue to engage in the future because often courses like these are just one-off. What happens afterwards? Where do I go from here? And this is something we have to think about, that you offer this course, they're really excited, and then you go back to everything else that was the same. So how do we navigate some of these things is something that we would love to discuss. My last slide is, how do we do this? How do we make it sustainable? That is absolutely critical. So one of the things that we have discussed with colleagues at the Committee on Human Rights and also people who are here is to build a consortium model where we're able to learn from each other and, given how limited the resources may be, benefit from different resources and offer courses that may be offered in multiple places. Bringing new institutions and partnerships, for example, for-profit institutions, non-profit institutions, members in the government sector, members in international NGOs, and how they can contribute in this regard. Exploring areas beyond engineering. I know this is about engineering, but certainly there are important issues in microbiology, in data sciences, in other disciplines that are just as important as engineering or as political science or as international relations. And finally, it is important that we also talk to institutions that have a lot of people who have been forcibly displaced. Community colleges are one such place. In Boston alone, you have communities from Haiti and Cambodia and Afghanistan and Sudan and elsewhere. And those students may have a lot to offer whilst also learning from each other. And certainly, I think none of this would make any sense if we were to imagine this to be only US-centric. It has to sort of incorporate the lived experience as well as engagement of institutions outside the US. So I'll end here. As I mentioned in the very first slide, please do reach out. And I also want to thank my wonderful colleague and student, Rana Hussain, who did a lot of the work in putting this together. So with that, I will move to Bernard.
Good morning, everyone. Thank you. Thank you so much for inviting me to speak at this forum. What I want to do this morning is to share with you some practical insights about the relationship between human rights and engineering. I come from a practical point of view. I'm the founder of Engineers Without Borders. Over the past 20 years, I've worked in very difficult conditions in Afghanistan and Gaza and so on. And so what I'm going to share with you is based on my own experience. I have seen children die in front of me. I have seen children blow up in front of me. I have seen things that I would not want to share with you today. When we talk about the practical aspect of the linkage between science and between engineering and human rights, we need to look at it from different perspectives. We can look at it from the link between engineering and society. Society depends on engineering, engineering depends on society. It may be obvious to us today, but about 40, 50 years ago, until Carson came along with the issue of DDT, engineering had nothing to do with society. So we have come a long way. When we look at the linkage between engineering and society, engineering and human rights, we also need to look at this diagram here, this photo here. Engineering has done a great job. There's no doubt in improving human development and security over the past, essentially, 100 years. Life expectancy in the United States gone from 47 to to what it is today, 77 plus, over 100 years, and engineers have contributed to making that a reality. At the same time, there are about 3 to 4 billion people on the planet whose job is to try to stay alive by the end of the day, for whom human rights are violated on a daily basis. Water rights is human rights. Energy rights is human rights. Security rights is human rights. And that's not in Africa. That happens in our own backyards here in the United States. How do we condemn that? What is the role of engineering in addressing those abuses of human rights at different scales and at different contexts? Plain and simple, we don't teach our young people about human rights. It's usually integrated in some kind of a fuzzy course in ethics. But believe me, if you want to learn about human rights is not an intellectual exercise. You've got to go to the field. You've got to see the violations. You've got to scream. You've got to cry. And you've got to do something about it. That has been my experience. The bottom part of this photo here, of this slide, shows how human rights have been violated in many countries in the world by engineering. Look at Bhopal. Look at DDT. I mean, at one time, trucks were spraying DDT on kids because that was fun. Look at deforestation. Look at the children who should be in school instead of working on waste dump. Look at pollution that has been created by the extractive industry, and the military industry has also contributed to the violation of human rights. I was in Gaza, near Gaza, about 2 months ago. I can tell you it's not a pretty picture. You want to see the violation of human rights, you go to the field, you don't talk about it. So when I teach engineering, I remind the students, what is engineering about? For most people, in fact, in the streets, they have no clue what engineering is about. They're saying, engineering is about technology. Really? Technology is about solutions. And engineering is about making sure that all human beings have fulfilling lives, meet their basic needs, and live with dignity and at peace. All human beings. That include people in minorities, people in Africa, people everywhere on the planet. How do we accomplish that? That's our mission statement. It's not to provide technology. Technology is a subset of what we do. A monkey can put technology together. An engineer has to think about how that technology impacts people. So here's a question for you, and I've been asking that question for 40 years now. I'm retired. Here's my answer to it. Do today's engineering graduates, educators, and practitioners have the skills and tools to address the global problems that our planet and humans face today and be facing within the next 20 years and beyond? Yeah, goddamn big issue on this planet today. We are living in what's called a VUCA world, vulnerable, uncertain, complex, and the A is ambiguous. How do we train students to work in that world? The students who are graduating today will be in positions of management 10 to 20 years from now in a world that we don't even know about, and they will be using tools that have not been created yet. Why on earth are we educating young people today in 21st century institutions using curriculums that were developed in the 20th century and in instructional structures of the 19th century? Duh! We've got a problem, folks. We've got to change so that our young people can address those global issues that we are facing today. On top of that, those global issues are not linear. They cross all over the place. Our education today should be transdisciplinary. Why? Because the issues that we are facing today are transdisciplinary. Yes, look at the campus. Campus consists of little boxes. We're going to put you in mechanical engineering. We're going to put you in civil engineering. We're going to put you in science. Well, these are the vertical silos. We are really good at silos. When most of the problems on this planet are horizontal. For those of you who know about the dot product of two vectors, the vertical line is one vector. The horizontal line is a horizontal vector. The dot product is 0. There's no intersection whatsoever between the real world issues and how we train young people in the schools. Our young people are bored to death. Have you ever been into a classroom lately? Why? Because essentially they are trapped into those vertical silos, and most of the problems we face today are global, integrated, systemic. They require young people to go to the field, to talk to people. So, 2 more slides. I think that I want to, if I were to, I've never been a dean, I would never want to be a dean. But if, my God, I mean, if I were a dean, I would have an office on the first floor so I could throw people out of the window. But I can write books, and I've just finished a new book on engineering for peace and diplomacy. How do we develop a new generation of engineers for the 21st century in 21st century institutions with a 21st century curriculum? Engineers need to be called change makers, peacemakers, social entrepreneurs, and facilitators of sustainable human development. We need a lifelong engineering practice, lifelong. Again, 20 years from now, people will be working on projects, on problems that do not exist yet. They will be using tools that don't even exist yet. How do we prepare people to practice engineering in a lifelong manner? How do we integrate ethics? How do we integrate culture? How do we make engineers not boring, but citizen engineers and globally engaged engineers? On the right-hand side, I show some pictures of Engineers Without Borders. I started that organization 20 years ago. We have 17,000 members across the United States and about 80 different Engineers Without Borders around the world. Our students go to the field. They take a project for 5 years. They integrate that project into their education. That's how you learn about ethics. Believe me, I've seen children, some children, I call them kids, in my groups of Engineers Without Borders, we saw people die in front of them. Believe me, when they come back, they are changed forever. How does education change the young people today for tomorrow? They are not static. They need to be dynamic. So Engineers Without Borders is a fantastic organization. For those of you who don't know about it, we take projects in all sorts of countries. The Engineers Without Borders work in Afghanistan for 7 years, from 2003 to 2010. How do we empower people? How do we empower people at the local level? Everywhere I go, or have been, I have seen violations of human rights. Everywhere I go around the world, I have seen creative people who want to do something about their livelihood and well-being and want to make the world a better place. Let's empower those people. Let's create essentially a change, a revolution based on the heart and mind that brings compassion into the world. Engineering without compassion is actually dangerous. How do we bring compassion into engineering? Action and compassion. Action without compassion is dangerous. Compassion without action is a bunch of tree huggers on steroids. So here's my conclusion. I quoted Albert Einstein. He's quoted a lot in this institution. The significant problems we face cannot be solved at the same level of thinking we were at, we created it. Abuses of human rights, poverty, injustice have been created with a mindset that needs to be replaced. We cannot use that mindset to solve those problems, period. So in this institution, National Academy of Engineering, National Academy of Science, it is time to develop a mindset. And who does it? Each one of us. Believe me, the young people are ready to change. How come there are not too many young people? I see some older people, not younger people in the audience. How come there are not young people in the audience? How come they don't speak here and tell us what they want in the world? How come it's always the 70-plus years old who essentially tell the rest of the world how to jump? Let them retire. We need young people to come and tell us what they want and how they're going to address the problems of the world that we are facing today so we can make the world a better place. Thank you.
Okay, hi everyone. So I have been drinking Bernard's Kool-Aid for many years. So I'm hoping that I can give you an example of how I've tried to address some of these things. So my name is Mira Olson. I'm from Drexel University. My background is as an engineer. I'm a water resources engineer. And I've had the pleasure of building a program in peace engineering so to Charlie's first questions, what does peace building bring to engineering? What does engineering bring to peace building? Some of the things that we're doing. So I had the pleasure of being able to sort of design it, think about what you would teach around these intersectionalities, building it and coming up with what would be a degree program, a master's degree program that merges peace building and engineering and prepares engineers to work in conflict or unsettled regions. I'm doing the same now with an institute in France. It's an engineering institute. It was founded by a humanist. It's always brought together humanities and engineering. And they're now thinking about how to develop education where it's partnered with an NGO that does humanitarian work on the ground and a humanitarian training institute. So that's kind of my background as I come to this work. And I think as we've been hearing that students are really eager to be engineers in pursuit of many things, in pursuit of environmental protection and social justice and human rights and peace. And I'm really glad that the first panel kind of brought up those intersectionalities and how they overlap sometimes. When I look at my own institution, we have a student-led initiative to bring environmental justice into engineering curricula. We have a university-wide initiative to bring social justice into all curricula that came from an anti-racism task force. We have groups of sustainability. We have a program in peace building and engineering, and it must be very confusing for students. So I think it's maybe our responsibility as our group here to think of what is that umbrella. And maybe Maya's suggestion that it was human standards, whatever it is, peace has made sense for me as sort of an umbrella for integrating all of these different principles together. And in doing so, I've thought about different ways that we engage. We do research, we do education, we do design, all of them to elevate those values within the practice. So if we look at, and we're talking on this panel about how we do engineering education, and we all teach engineering ethics, accredited programs all do. And as Mohammed was mentioning, often it's design focused, or it's a standalone course, or sometimes it's embedded approaches into discrete things that we're doing. And as a result, students are able to look at engineering designs and evaluate them with different frameworks, maybe a human rights framework, maybe an ethical framework, maybe a conflict-sensitive framework. And the result is that students are able to do that with the existing body of engineering that we teach them. So engineering designs and structures they can look at. But how do we take those next steps? How do we effectively value human rights in the entirety of engineering education? How do we shift the responsibility of engineers? So Shireen's example of developing a vaccine for COVID. So developing a vaccine does not impart immunity. Getting it equitably into everyone's arms is what brings immunity. Where does the responsibility of the engineer end? How do we educate engineers so that they take those extra steps and say it's not just designing the thing, it's making sure that it's accessible. It's making sure that it's universally available. How do we bring that into education as well? And can we get to the point where human rights drive engineering, education, and design? So I'll give an example. I'm teaching a class right now in hydrology, and because hydrology often teaches how to manage stormwater, we're talking about how to design stormwater basins. And my students feel very good about being able to manage water, hold it for flooding, and then we take a couple steps back and we say, what's the matter with flooding? Is an accumulation of water in one place particularly undesirable, that we want to store it, and we keep taking steps back. And why is there an accumulation of water here? Is it dangerous? Are there people there? Are there buildings there? Is that why we're trying to manage this water in urban areas? So who owns those property? Who uses those property? What resources do they have to deal with the rising water in different ways? So if you keep taking steps back, as I ask my students to do all the time, to think about why we're doing something, you sometimes get to a point where they're able to think about designing for basic human needs and basic human rights and peace outcomes. But then we have to be comfortable as educators that what they come up with as a solution might not be the stormwater basin to hold all the water. It might be an evacuation route. It might be a communication plan. And so we have to take a look at what we're teaching and how we're preparing students and what's driving what we do. So that's a motivation of mine. And something that I found really helpful is a framework that we sort of developed over time looking at conflict-sensitive engineering design. And I put up on the left the framework for life cycle assessment because this is something that most of us are familiar with because it didn't take very long, probably just a couple of decades, for life cycle principles to enter into the design processes in ways that are practical and that we know how to use. We know how to look at, throughout a design process, what materials are being used, how much energy that takes, what wastes are generated, all the way through the design, the use, and the end of life. We got comfortable with that fairly quickly. Can we do the same for social impacts? So in the design side, who has input into this? Who needs this? Who's going to use it? Who's going to benefit? If you're designing for someone and they are using it, what happens to the non-users? Are you creating a disparity or further dividing an inequity? How could it possibly be misused? So the example I think it was Tyler gave earlier about Facebook, it wasn't designed to spread hate speech, but can we make it the responsibility of the engineer to circle back when that's what it's doing, to keep innovating, to keep designing? That is within the box that we draw around our engineering problems. It becomes our accountability and our responsibility. And so we think of that throughout the whole life cycle. So once you're using something, who is employed? Who has access to it? Who's missing out? How do we design differently? In a class that I co-taught with political science, it was an introduction to STS methods. We had students, they were looking at examples of technology and they were looking at benefits, some of these questions. Who was using it? Who did it benefit? And who was missing out? And we asked them then to go back and redesign or rethink the design process. Who you're trying to, so as a designer, who you're building things for. And think about how that might look differently if they wanted to be serving the needs of other people. And to a group there, I still remember this, there were 6 groups in that class. Every single one came back with a redesigned product. They had taken their technology and they had jumped right to how they would make it better. What we had asked them to do is rethink how you would design together a more inclusive, and none of them did that. So that's something that we are inherently not preparing our students to be able to do, but I think in some of the examples that we've been hearing, the co-partnered the design, the participatory methods is where engineering should be going. So I'm just going to leave you with some examples because we want to leave time for questions. But these are just some examples of things that I've been personally involved with, both in the undergraduate and the graduate level, in terms of incorporating human rights, peace building, social justice into full-out graduate curricula, research. So this takes a long time to have co-partnered industry and NGO partnered research, figuring out what those questions are, doing that in an intentional way. And then also to the undergraduate, where you're putting in course by course or project by project, even if it's something as technical as thermodynamics, how to bring that all back into the realm where what's driving what we do is not the product, the design, but it's why we need it. It's the need, it's the human need. So I'll leave it there, and we'll take questions.
Thank you so much. I really appreciate the time that I had told both of my colleagues to do that. As promised, let's start with 3 questions from Zoom, and then we'll come to in person. If whoever is the... Yeah, go ahead, please.
Hi, everybody. Okay, so I have a few questions from Zoom. First, from Ethan Eagle. Dr. Z, how do you consider balancing student interest that they pay to learn and their privilege as they work on issues? How to work with the forcibly displaced and not for?
Yep.
Where do students ask who matters most and embrace discomfort?
Absolutely.
So that's the first question.
Okay.
Kirsten Dodson asked, building on Dr. Amadei's comments, how do we engage and encourage younger generations to value the connection between human rights and engineering when sometimes it feels hopeless, like the mountain is too tall to climb?
Yeah.
And Jonathan Mervick asked, what can we do as engineers to fix the deeply societal issues with the tools we make? What use is a hammer to someone facing homelessness? Anyone in a machine shop will tell you every tool is a hammer. Okay, so small questions.
Great. I'll take the first one from the colleague about privilege. So I think that's a really important question, but my answer is that my role is first and foremost is to be an educator, right? This is not a class where people are rolling up their sleeves and solving problems. This is a class to really understand first and foremost, why do people migrate? What are the drivers? What are the challenges? And how do we as engineers think about it? Part of this issue is to engage with voices of those who are displaced, and we try to do that both in their writing and their interviews. But more important than that, I think it is the recognition that this is a problem that requires engineering approaches. Subsequently, we hope that many of them will work with those who are forcibly displaced, but I'm not even at that level yet. I'm at the pre-level of that to really understand what the problem is, what our role and responsibility is, and how do we move forward. So I'll go to Bernard for the next one, and perhaps Mira, if you have thoughts on the third one.
I kind of forgot the question, but I think I can guess it. The idea of why is it that engineers essentially are bored in the conventional education? I think if you look at the engineering curriculum, 4 years, especially in the United States, 5 years in other countries, it's mostly learning from books. And we know the reality is quite different from books. I think that one way of remedying that is to make sure that the students are exposed to some real projects as they are studying from the books. The best model of education I have seen in the world was when I visited the Kigali Institute of Technology in Rwanda. What do they do first? First semester, they send the students to a village. They take a village, any village, and they're going to stick to that village for the next 4 years. Then they go back and they study the books. Then they go back to the village, and they go study the books, and they go back to the village. At the end of the 4 years, they have captured all the basic fundamentals of engineering, and they have contributed to the betterment of that village. In fact, they have to defend a thesis showing how the village was initially and how they did at the end. Another program that I admire is the program at Drexel University. It's 5 years instead of 4 years, but it has a co-op program where students go, 6 months, they study books, 6 months study books. You've got to integrate real practice of engineering into the curriculum. And the sad part is that most faculty members I've interacted with over the past 40 years have zero to little practical experience. Where do students learn that practical experience? Where do they learn ethics when it's never mentioned in the classroom? I've been interested lately about conflict management. Where on earth do we teach young people to deal with conflict? It's a conflict. Never heard of conflict, really. Conflict with yourself, conflict with family, conflict on an engineering project, conflict when I work in a community somewhere in the world. There's conflict between different tribal components of the community. Where do we train? Where do we train? Again, I think it's creating what I call globally engaged engineers, not global engineers, globally engaged engineers who know about themselves and who know essentially how to interact with different stakeholders through experience. Otherwise, engineering is boring. I tell you, it's boring. Try it.
Yeah, I can take the last question was about how we think about or justify the tools that we make. So if you think back to like ancient civilization, first engineers, we were designing things that we needed. You needed shelter, you needed roads, you needed water. So we were designing things that we ourselves were using. So we knew that we needed them, and we knew what materials were around us and available to use them. Fast forward to now, we're designing things using materials from all the way across the world for people, millions, billions of people who are going to use them, who we'll never meet. And so we've lost that feedback loop of, do we need this? Do we have the resources to support it? In building it, are we depleting natural resources that we've lost that connection? So I think we have to force ourselves to, at the beginning of the process, not at the end, ask ourselves those questions of who needs this? Who's going to use this? In your example, does a homeless person need a hammer? Who's going to use this? What are they using it for? What about the people who don't need this? And we're still investing that. So I think we have to adopt that framework and start asking those questions at the beginning before we work on things. Naturally, university engineering research is generally funded by defense, oil and gas, so the tools that we've developed have fit those needs. But if we ask ourselves those questions up front, who are we designing this for? Who needs this? What are we using? We'd probably get to different things that we'd build.
Let's take 3 questions from the room as well. So, and if you can, colleagues can introduce themselves as well.
Sure. Is this on? Okay. Hi, my name is Rachel Law. I am a Science for Development Fellow with the U.S. Agency for International Development, but was in academia for the past 8 years and just wrapped up my PhD in civil and environmental engineering. I'm a disaster engineer by training, so I model natural disasters for the purpose of looking at appropriate mitigation responses. So my question is this, real quickly. I typed it up because I knew I was going to forget when I got up here. So kind of to Professor Amadei's point, I am a byproduct of the higher education system. But I also almost left the higher education system, left engineering, because I could not succeed in a traditional linear classroom environment. And I think it's been a discussion in higher education circles for a long time now that higher education needs to change how they teach, but also higher education doesn't have all of the tools and resources for students to necessarily go off and be the people that they want to be going into higher education institutions. And that's no fault to the higher education entirely. But I think there are ways that we can supplement that. My question is this. How, within the context of higher education, how do you and educators in the room who are attending today realistically equip students to go out and contemplate and act? How do we encourage our students to be uncomfortable? Because the biggest crises and global challenges of today are hardly solved from the comfort of our own homes. So most of everything I learned in higher education, or in engineering, I learned in the field and through global experience. And I have had privileges that have afforded me those. And I know that higher education is different in that regard. But I think individually, how can institutions work with students and their personalities to be able to actually conjure change for them?
Popkin from the Human Rights Center at UC Berkeley. All 3 of you mentioned numerous times the integration of both ethics and human rights. I have worked quite a bit with technology companies and engineers in technology companies, to kind of address human rights issues. And those companies often have human rights principles, and they often have AI ethics principles. I'm curious how each of you see kind of the balance between ethics and human rights and how you talk to your students about that.
There was one more question I think Jackson hadn't had. On the right,
I think one of you mentioned this. When you think about effects on communities, you have to figure out how you close the loop relative to what a student, a putative engineer sees in the environment he or she is in, and the larger way things play into a global framework. And one of you mentioned supply chains. You also mentioned extractive industries. So a question becomes, how much in terms of life cycle analysis? Are people thinking about what electrification really means in terms of battery technologies, how they are developed, where the materials come from, who's doing that extraction, etc. I think these are the kinds of questions that kind of go through what all of you've said, but particularly you, Professor Amadei.
So let's start with the first question that Rachel asked, and Bernard, I'll go to you, about the need to rethink the higher education model and where it is failing in terms of getting students to think deeply about the issues and also finding value and meaning. What do you think?
It's a good question. I don't have a definite answer. But let's remember that the students who come to university went to high school before. I think that for young people to understand their place in the universe, their citizenship, their obligations and their rights, you don't learn that at the age of 18. Hopefully you learn it before that. So when you enter the university, you already have a background. I think high schools do not talk about ethics or conflict or, I think that's where you start. You start as early as possible. Sustainability. How come we don't talk about sustainability in kindergarten so that it's become second nature across essentially the entire educational system? So, as an instructor, as a professor at the university, I can only do so much with what I have, right? I mean, if I have students who have never traveled, students who have never heard of a culture, students who have never understood poverty, have never seen poverty, it's hard to explain essentially those concepts to the students. My best way, what I've done over the past 40 years, was to bring students in uncomfortable situations, not risky, but uncomfortable situations, eye-opening situations. I can tell you over and over, taking teams of students to different countries in the world, even like right now, I'm doing some work in southern Colorado, essentially poorest county in the state of Colorado, high states of cancer, high states of miscarriages. They drink water with cyanide because there's a gold mine upstream of them. Is that normal? No, it is not normal. And that's in the good old United States of America. So we need to identify essentially those conflicts of interest, those violations of human rights, and we've got to denounce them. Problem with engineers is they are not involved in a political decision. Engineers go solve your own problem there. Yeah? The decisions are made by individuals who know little about technology and who know little about science. And it's not going to get any better over the next 4 years. Sorry, I had to point that out. So how do we train engineers to be citizens engineers, globally engaged engineers, more than just providers of technology? It's through experience. It's through experience. I've done it for 40 years. And each time the students come back and say, whoa, I did not know that people did not have any water. I did not know that people did not have any toilets. I did not know. Whoa, I have changed them. I could have asked them to read a book about it. That would not have changed them. When they experience something, they change. All of us do that. When we experience something, we change. We become aware. And once you become aware, you can change. But awareness starts first. And awareness is not written in books. Poverty is not an intellectual exercise. A violation of human rights is not an intellectual exercise.
Let me take the other two questions, Bernard, and move to Mira, both on those perhaps. The integration of the practices in human rights in the classroom setting, and also the last question on... Sorry, thank you. And the last question, the question first by Betsy, on integration of human rights in the classroom, and then the last question on effects on the community and really rethinking of what it means for the community if we do these things.
Yeah, thanks. I'm loving this format of asking multiple questions because I think in doing that, some of the other questions answer some of the earlier ones. So bringing up Rachel's question about how do you equip students to contemplate their acts, And I think you brought up closing the loop. I think that's actually the answer in doing a lot of that. And so it's dispelling the notion, as Bernard was saying, that learning happens exclusively in a classroom. We know that not to be true. We know that we can learn anywhere from any people. And so also getting rid of the notion that education happens from professor to student. So one mechanism for education that has been really effective for me, we offer these side-by-side classes where it's an instructor at the university and also a community member. And the students are made up half of Drexel students and half community members. And there's a curation, but it sort of breaks down the thought that education comes from the university out into the community. Really, it's that knowledge is garnered from many different places, and it's our job as thinkers, students, everyone as students, to coalesce that, to bring meaning from what we're learning from lots of different places. And so can universities do that? Yes, it's a different model. But I think that's a good way to approach that. Because what we have missed is sort of closing that loop, seeing what happens, what are the consequences of this, who does it affect, and how do I change, and how do I iterate and change that, the cycle of consequences.
I'll add just things to both of last questions. I think one of the things that we have done is reading as much as possible of people's literature or poetry or things like that from the communities, their voices. Oftentimes it is not possible to go in a classroom setting to some of these places. Oftentimes engineering text doesn't capture that, but literature does, and poetry does. So one of the things we do in our classroom is, the students, I tell them they should read a book. It could be Goodnight Moon, I don't care, but read something. But oftentimes it is something of that nature. And also, one of the things that we have tried to do is to look at not successes, but failures. And that tells you, is the failure in human rights? Is the failure in not following the law? Is the failure in not understanding somebody's full dignity? And where does the engineering technology fail? So it's imperfect, but it allows us to think about some of those things. We'll take perhaps 2 more questions. We have 5 minutes. We'll take maybe 2 questions from the Zoom. I'm just making it up, as you can see.
Add one more thing quickly. I just want to add that the responsibility of an educator is also to think about your community partners. It is our job to stop and think and create educational material for students. Someone who's working on the field, they have another job. And so it actually is sometimes a burden and a time sense. So I'm very, very careful about asks and collaboration and to setting up those partnerships. What does it mean to learn together? What does it mean to do research together? Has to be a very intentional and open process.
So 2 questions from Zoom and 1 from in person here.
Okay.
Go ahead.
Great. So Nathan Smith on Zoom asked, do you have advice for students who want to engage in these topics but don't see existing courses offered at their universities? And Ali asked, could you talk about how you engage professionals to mentor your students?
And there was 1 question here in person.
Oh.
But there are 2 questions. Good to go. Yeah. And
So a lot of what I hear being discussed is our students aren't morally shaped by the time they come to the university. And in some ways, we're asking for engineers to have a certain set of ethical norms that frame the way they engage in practice within engineering and in science. And so I'm wondering, is there any code of ethics that exists among engineers that would then properly incorporate some of these things that we're discussing today? And then obviously education of becoming an engineer is going to also include education within the code of ethics, which is an acceptable and expected standard of behavior. And then lastly, whether or not that might help push back on some engineers feeling that they are forced into engaging in engineering practices by their corporate bosses that then would lead to effects that they don't feel comfortable with or that they're not really aware of. Thank you.
There's 1 more question right there.
Mary Rednofsky. I'm a retired professor of interdisciplinary curriculum design, and I also consult on human rights for persons with disabilities. My question is, at the systemic level of a university regarding teaching, and also involves NASA's philosophy, which was coined as failure is not an option, and yet unofficially at one point. And yet NASA knows that you have to go through a lot of failures before you can ultimately succeed. But I'm afraid that that little saying has caught on with education and with a lot of other fields. And students have picked up on that, assuming that failing at doing something along the way, during the process, is not an option, which of course is not true. So in the university system, professors also feel the same stress of not failing in multiple senses of the word. So how do you change the university culture so that not only professors can encourage this ability to fail successfully and then teach the ultimate successes for the students?
Great. We have about just a couple of minutes left. I asked both of my colleagues here, take any of these questions. I hope the conversation continues quickly, maybe in a minute or less. Then I'll just repeat the questions. If your university does not have options, what do you do? How do you engage? Thank you. Sorry. It's like you're on mute kind of a thing, right? I mean, if your university does not have options, what do you do? How do you engage professionals, code of ethics, and changing university culture? So let's first go with Mira and then to Bernard.
Okay, those are big ones. So I think, I forget who's earlier said that we had to form consortia, so coalitions of different universities who are offering things. So if you're a student and you don't see the offerings where you are, look elsewhere. Don't leave, but study abroad. What courses can you take other places? Can you take a little bit of initiative and enroll for a course at another university and get credit for it where you are? I'm a huge proponent of co-teaching. We've seen examples of that in here with professionals. I could not teach a peace engineering course as an engineer by myself. I often co-teach with peace-building practitioners, people who bring on-the-ground knowledge and bring that in. And I think that also helps change the culture slowly, incrementally at a university. I could go on about that, but I think just bringing different voices, that it's not always the people that you think you're going to be learning from. So bringing all of those together both creates the discomfort and the ability to say, I don't know, and bringing that into the conversation and normalizing that is sort of a good start.
Final thoughts?
Regarding professional involvement, with Engineers Without Borders, all teams, if it's a student team, they have 2 or 3 professional engineers working with them, reviewing the design, going to the field with them, giving them guidance. And we also have half of our chapters are professional chapters of individuals essentially who donate their time and work on various projects around the world. We are working in about 48 different countries. We concluded our 1,000th project last year. But students are always surrounded by professional engineers. Why? Because they learn the ropes by doing. And at the end, after doing it for 4 years, guess what? They get a job.
Well, thank you very much, everyone, and I'll pass it back to Charlie.
Thank you very much for the panel. Please give them a hand.